Hey everyone, welcome to another episode of Visual Studio Toolbox. I'm your host, Leslie Richardson, and today I'm excited because we're talking about one of my favorite topics, good old debugging. The topic that everyone dreads, but we're all having to do as developers. But we're going to start from square one today, talking all about how to get started debugging for the first time in Visual Studio. And joining me to do that today is Nick Proud. Hey, Nick.
Hi, Leslie. Nice to see you.
Nice to see you too. So before we jump into debugging, do you want to tell us a little bit about yourself?
Yeah, sure. So my name's Nick. I'm a software developer from the UK, near Manchester. I'm currently working as a director of software engineering for a robotic process automation company. We use a lot of .NET in our stack. Just excited to talk about debugging.
Awesome. I'm excited too. I used to work on the Visual Studio debugger. So yeah,
Amazing.
debugging is near and dear to my heart.
Yeah,
Cool.
definitely.
Yeah, so for those who don't know what that is, or maybe are getting started in their coding journey, what is debugging and why are we stuck doing it?
Yeah. So unfortunately, it will be like a really common practice for you. So many times people say, "What are you working on?" I'm just debugging this. I'm debugging that, and it's kind of quite a negative connotation to it, but it's essential. And the simplest way I could describe it is you're tracking down that pesky bug. You're trying to find the root cause of a behavior that's happening that's unexpected. And so using Visual Studio, we can, rather than let the code just run through in its normal state, we can actually pause the code and inspect it to see what the current state is and how that might be contributing to the issue that you see.
Awesome. Yeah, I think that's a great definition. So, yeah, should we hop into Visual Studio and see how to get started?
Yeah, let's go for it.
Cool.
So I've just created a typical console application. So whenever I do a demo, I find it really easy to just build a normal C# console application with a main method and then to jump right into it. And so the first thing that I want to talk about is the compilation modes that you can see in Visual Studio. So you've probably seen already that you've got this debug drop down and you get the debug or release options in there. Now, for the purposes of what we're doing, we obviously want to be in debug, but it's not obvious what the reason for that is. So there's different modes of compilation for C# in particular in Visual Studio. And the difference being that when you're in debug mode, which will be your default mode, there's a little bit of a difference in terms of the way things are compiled. We have things called symbols that allow will allow Visual Studio to know where you are in the code, and it's less optimized. It's as you know, Leslie, it's quite a complicated subject. I won't go too deep on that, but just so you're aware of its existence, the default mode will be debug. And then on the flip side of that, release mode is kind of the opposite of that. There's more optimization. You don't have those symbols that are telling you where you are in the code, simply because you aren't expected to be debugging in release mode. So that's the difference between the two. And the reason I talk about this is because one of the debugging aspects that you can take advantage of in Visual Studio is something called preprocessor directives. So these are the lines you see here, where we've got this little hashtag symbol. And this is where you're adding a condition into the way the application is being compiled. So it's not the same as like a conventional if statement. It's something that sort of sits outside of the code. It's more for Visual Studio's benefit. So for here, for example, we're simply saying that if the current mode is debug, then we want to execute some specific code. Otherwise, it's going to be in release mode, and we can execute this code. So I can demonstrate that, and it will also demonstrate a breakpoint. So we're kind of killing two birds with one stone there, hopefully.
Great.
So I'm currently in debug, so I would expect to put a breakpoint in here. A breakpoint is what we were saying before about pausing your code. It's a point in the code where you can say, I don't want you to run further than this point. I want you to stop at that point so I can take a look around and see what's happening in the application. Now, obviously, if your breakpoint is inside an if statement, and that if statement doesn't evaluate to true, you won't hit your breakpoint. So we're kind of testing the if debug scenario by saying we're expecting this to hit that breakpoint because we're in debug.
Yep.
And so in Visual Studio, to kick the program off and start debugging, we can go to the top here and click the play button. And let the application fire up. And then, as you can see, we've hit our breakpoint. And as we said, the reason we've hit that is because we're saying only go to that breakpoint, only write out this line to the console if we're in debug, and we are. And we've also put a breakpoint there, so we're now paused.
Great. Pretty simple. Also, I gotta say, shout out to the debugger team for adding the ability to see that you can actually add a breakpoint in the first place by hovering over the gutter where you just added that breakpoint that used to not exist. And I can imagine if you're like brand new, because a lot of schools and a lot of classes that you take don't always teach debugging. So if you're just trying to figure this out on your own, it's like not very intuitive maybe to to know that, oh, a breakpoint is here. So yeah,
absolutely echo that. And you guys, if you're picking up Visual Studio for the first time, you're kind of spoiled, to be honest. The feature set's amazing. I was writing VB6 in the old Visual Basic, and it was a fantastic tool, but it's come so far. The debugging experience has since then. So
it's super powerful.
And obviously, if we want to test our theory around whether the release breakpoint would hit, we can add another breakpoint here and then change the mode over to release. So now this preprocessor for if debug, it should evaluate to false. So we shouldn't see it hit that breakpoint. So I'll just click play there. And there we go. We've hit the other breakpoint instead because we're now in release mode. So you can see the way that breakpoints can be affected by the position you put them in. If they're inside some logic which wouldn't normally be hit in the code, you can guarantee the breakpoint won't be hit either. Okay, so we've talked a lot about breakpoints. So along this part of Visual Studio, you can tap those in and they'll appear and disappear. You can also, there's quite a handy function that you can use in the debug part of the ribbon where you can say, I just want to turn off my breakpoints. I don't want to delete them, but I just want to disable them. And I find that quite useful if I've been debugging something for a specific change, because there's a common misconception around debugging, in my opinion, that it's always to do with bugs. It's actually sometimes around testing as well. You've got a feature that you're adding. You want to make sure that the code's running the way you want it to. And I find that using breakpoints for that is a fantastic way to verify what I'm doing. And so when I've made that change, I want to see that it carries on through without me stopping it all the time. So being able to disable things in one place and then re-enable them is really, really useful. So I want to talk about steps. So there's lots of different ways you can perform these steps. And steps for me essentially are ways that you can move around the code once you've breakpointed. So once you've paused the execution of your overall application, you've got lots of different options. You can either step into something, you can step over something, and you can step out of something. When I say step into something, it has to be something that you're capable of stepping into. So if it's a variable, if it's just a variable like this, where we're specifying or defining an integer, you're not going to be able to step into that because there's nothing inside to step into as far as debugging goes. But for a method or a function, you've got code inside that. So you can choose to either step over it and skip going through every single bit of code inside that method, or you can step into it. But don't forget that the code inside it, if you go over it, it will still run. It's not saying we're not going to run this code. We're just not going to follow it through for the purposes of debugging. So I've got a method here called step into method. And if I go to the definition of that, everything I'm doing here is really super simple. I'm just writing things out to the console. But if I'm debugging, I can choose whether I want to see the code go into this method, or if I want to just step over it. So I'm going to set a breakpoint here, and then I'm going to run the application and let it just breakpoint onto that method. And then up on the top left, here are your step actions. And as you get really good at debugging, and it becomes second nature, I'm sure, Leslie, this is you. You're just tapping the key combinations, F10, F10, F10,
Yep.
F11, step in. And it just becomes like muscle memory, right? It's just, it's amazing how quickly that can just become done without thinking.
Oh, yeah. And plus, I mean, again, you're probably going to be debugging a lot in your coding career, coding journey. So, yeah. You're probably going to learn those keyboard shortcuts very quickly. As somebody who does not usually remember keyboard shortcuts, F10, F11.
Yeah. Because I was thinking about the disable all breakpoints and delete all breakpoints, all that sort of stuff. And I was like, oh, what is the keyboard shortcut?
Yeah.
But you can guarantee, stepping around is like just one tap. It's sometimes you can go a little bit too fast as well. I can just step through things and go, oh, I've gone past it. And
luckily there are additional advanced debugging tools in VS that can help you backtrack if you do that. But we won't get into it here because that's
you're thinking of everything.
It's great.
So for this one, I want to step into it. So I want to actually go in and see the code that's going to execute. So I'm going to hit this step into button, or I can press F11. And you can see we've actually gone into that method, and then we can do the same thing for the lines of code that are inside the method. So you may have a method within a method. And so you step into the first method, and then you decide, actually, I want to look inside that method as well. Or you might think, no, I know that one's good. I've tested that one. I'm going to step over it. In which case, you can just do the step over here. So you can see these arrows, handy little arrows that just explain what kind of step we're doing. And there you go. We've come out of that now because it was the last line of code for that method, and we're on to our next one. So I'm sure you can guess what I'm going to do next for step over method. I'm going to decide that I don't want to look inside this. So I'm just going to click step over. And the last one is one that I think a lot of developers, in my opinion, I don't know what you think, Leslie, but they potentially use the least.
Yeah. I don't use it.
Yeah, it scared me a little bit when I first got into code, because I wasn't sure where it was going to go. Even though now it's more obvious to me with experience, but I don't know. I think there's a tendency to, rather than stepping out once you've decided that your code is good, that you just keep going through. Is that the same for you?
Yeah, I kind of feel the same way. I very rarely step out, in part because I get worried. I'm like, I mean, I think I'm pretty sure I know where it's going to go, but let's just go through the rest of this method anyway.
Exactly. It's just safer to keep going a lot of places.
Yeah, that 2% uncertainty is like,
yeah. But that's really interesting because it shows that people have their own debugging habits. There's different debugging styles. And you will get that person who will be step into everything, and that's fine. That's absolutely fine, because if that's going to give you the information you need, that's the way. But just to explain step out, essentially, it's whichever method or function you stepped into. By pressing step out, you can essentially go back up into the next level up, basically. So, like with if I look at step into. So another handy thing you can do, just press the method and then press F12 and you can go to its definition. We stepped into this, but say this had a long block of code and we got halfway down and thought, I'm okay, I don't need to look at this anymore. You can press step out and it would go back up to the point you were in the next level up. Obviously not me and Leslie, because we want to play it safe.
Yeah, but it's cool. Something I do want to point out is that breakpoints and the stepping tools, those are pretty commonplace in the IDE world. So if for whatever reason you're deciding to use something other than Visual Studio, whether that's VS Code or another IDE or advanced editor experience like VS Code, those tools will at the very least be there in some capacity. So you'll always have breakpoints. You'll always have ways to step through to see what you want to see.
Yeah, and in the browser as well. That's one that
Mm-hmm.
a lot of I find that a lot of developers that I bring in who are fairly new, they're less exposed to the browser debugging experience, but the concept is the same
Yeah,
essentially.
a lot of the same tools too.
Cool, right? This is one of my favorite features because it helps
Same.
you. It's so good. It helps you to debug very, very specific edge cases. You might be trying to figure out what would be causing a bug, but you know that it's only in a very specific situation. And this is the conditional breakpoints. And this is a breakpoint where it starts off as a normal breakpoint, but then once you've created it, you can then specify that it is conditional. So I'm just going to get rid of this one here. And I'm going to put a conditional breakpoint inside this for loop. So this is a loop where we're going to be iterating until we've reached our top index. And inside the body of this loop, we're going to be multiplying a variable by 2. But what I want to do is say, I don't want to be hitting this breakpoint for every single iteration. I only want to hit the breakpoint if a certain condition is true. And that condition for me could be that the variable condition demo value is greater than 5, because for some reason I've got a theory that something breaks when it gets to that value, essentially. So the way we can do this is once you've already set your breakpoint, you can hover over it and you'll see there's a settings button. And if you click that settings button, you get some really cool features that you can take advantage of. So in here, we want to first look at conditions. So I can check this conditions box, and it will give you lots of different options for the condition. But I think the most common one is going to be conditional expression. So this is a condition builder that you can use to say, if this condition is true, that's the only time I expect you to hit the breakpoint. You can also do it based on how many times it's already hit that line of code. So that's a similar sort of deal. You could say, if this line of code gets hit X times, then stop the flow of the application. I want to debug it. Filter, this is one I don't think I've ever used it. Leslie, do you want to share some insights into this one?
Oh goodness. Oh, filter. Because I
I'm putting
barely
you on the
demo
spot,
that one
sorry.
either. So I'm blanking. I feel like it's a slightly it's kind of like hit count, and that it's a slightly different variation of a conditional expression last time I checked, except yeah, look, what does
Oh,
it say
yeah.
this time?
Okay. It looks like it's like a just hit my mic, sorry. It looks like it's a
Sorry.
combination of conditional expressions. Yeah, based on, because
Yeah.
the debugging team put a handy example in there. So there you go.
Yep.
But
Pretty great. And I do
yeah,
want to point out you can add multiple conditions if you want. So like there is the add condition. The add condition button right below it where you can add more than one condition for
yeah.
whatever reason. So that is an option as well.
I think I need to put one in before I can do that, don't I? So if I did,
Yeah, I think so. Yeah.
so if I said, so it's kind of like a Boolean expression, isn't it? So it would be condition demo value is greater than 5, and then press enter, and then I should be able to add another one, and the hit count is 2, which it would be, or at least 1. Yeah, my maths is failing on me today. It's nearly night time in the UK. But yeah, for this one, we're essentially saying the condition is, I only want you to hit that breakpoint if my variable condition demo value is greater than 5. So for that, we can test that out. You can see, I've just deleted it. That's always good. Let's put that in again. Okay, enter, and then close. There we go. And you can see when you've got a conditional breakpoint, because you'll have a little cross in the middle of it. So from that, you'll always be able to see that it's slightly different. And also hovering over it gives you the conditions that you've set up as well. So I'm going to let this continue to run. So because we're already breakpointed, the play button says that we want to, it gives you the option to continue. And then you might be thinking, how do we know that it's actually above 5 at this point? could it not just be highlighting it on its first iteration? And this brings us to inspecting variables. So what we can do to verify that it is actually hitting that condition is we can hover over a variable while we're breakpointed. And you can see here that it shows a little tooltip telling you what the current value of that variable is. So we have indeed met that condition. That variable is 10, so it's greater than 5, and it hasn't breakpointed before that. So our conditional breakpoint was successful. Okay, so I'm going to stop the application, otherwise we're going to be constantly shifting down.
Also, before you go on, as we pivot away from breakpoints, those aren't the only breakpoints, fun fact. So the lesson here is to definitely take a minute to explore the Visual Studio Debugger, because there's tons of additional breakpoints. We've got like trace points, which is what Nick just highlighted. There's dependent breakpoints. There's function breakpoints, data breakpoints. So many to explore that can help you be a lot more productive in your debugging journey that are worth checking out.
Absolutely. It's so important, isn't it? It's all very well and good being good at sort of solving problems through your design of code, but if you don't know how to use the debugging features, you're going to be a little bit of a disadvantage. There's so many advanced features, like you said.
Like I can't speak for every IDE, but Visual Studio, I mean, the debugger is a lot of what makes Visual Studio really cool. If you take the time to check out some of its more advanced features, it's awesome.
Yeah, it blows my mind because it's the team has built something that's working on a running application. That's like next level for me. How do you interrupt the flow of the application? I wouldn't even know where to start.
Right.
Even as so another really cool feature is the watch feature. And a watch is essentially where you've got a variable of some sort, and you want to know while the application is running what its value is. So it's similar to where we hovered over that variable and said, what's the value? But we were only doing it for that specific point, that breakpoint we were on. But if you're breakpointing something else, or you're debugging something else in the application, and you want to keep one eye on another value to see if something's changing it, then a watch is often a good shout. So, for example, if I wanted to just keep an eye on this variable and make sure that it's definitely just 10 while things are running, I can right-click it, and then I can go over to... I may need to be debugging to actually see this, so I'll just put a breakpoint on it. There's several ways of doing it, as is always the case with Visual Studio. But if I get to... I'm in release now, that's probably why. There we go. So I can actually see it in this watch window here, but I'll just demonstrate here. If you right-click while you're breakpointed, you can see there's an Add Watch option. If you just click that, it will take you to the watch screen. I already had it in there by the looks of it, so I think I can right-click it and delete watch. There we go. But essentially, that's a screen that gives you all your watches. So it's everything you've flagged as, I want to keep an eye on that, basically. So we've got the variable name, the current value, and its type. Now, obviously, we've set that to 10, and we're breakpointed on it. And this is really interesting. The value here is 0, which is not the same as what the value is in the code. And the reason for this is that because when we hit a breakpoint, we're on that line of code, but the code hasn't actually executed yet. So we have a watch demo value, but because we haven't executed, we haven't initialized it with a value, it's got its default value, which is 0 for the integer. So if I then step over this and go to the next line, that code is then executed, the variable has been initialized to its value, and we can see here the value in the watches screen has also changed. So you can see how this would be really useful if you had other code which could potentially affect that variable. I find this really useful when I'm iterating through lots of different data structures. I think recently I had a big array of JSON objects, and I was going through it, and there was an external variable that got set based on a very particular field inside these JSON objects. And I wanted to see the point at which that variable changed. And so I could just put a watch against that variable, run through the iteration, and then I could see, okay, it changed at that point. That's the bit that's setting it, basically. Okay, so immediates. So these are probably, after the sort of usual breakpointing aspects, this is probably one of the things I use the most. I don't know whether it's because I'm more of a back-end engineer, but I don't know whether that affects it or not. But essentially, immediates are kind of like, for the web developers, they're kind of like the console in the browser. It's kind of like where you can interact with the code base while it's paused. So by that, I mean, if I was to type a variable which is in the code that has gone past the execution point, so say watch demo value, we're past that point now. Say I type that into here, I get IntelliSense for that as well, because the compiler knows that it's part of the code base, and I can say watch demo value, press enter if I want to, and it will give me the value of that. But I can, so that is essentially me interacting with the code base while it's in a paused state. And this is valuable for lots of different reasons. It allows you to test different theories while the code is paused. So for example, if you haven't got a watch on the watch demo value and you think, oh, I need to make sure that that is equal to 10, and maybe it's not in view, so you can't just hover over it and see it from there. I'm just trying to find an example of why you would use this in such a small application. What you could do is say watch demo value, and then similar to that conditional expression we used in the conditional breakpoints, you can use a Boolean expression. So you can say watch demo value is equal to 10, and that will return a true or false. So we can see here that's returned true. So it's really useful. I use this all the time when I'm looking to just check in on something that's still available to me as part of the code. It's still in scope to some point, but I'm probably halfway down the screen. It's out of view. I don't want to scroll back up to it. I just want to quickly use the immediates to have more of a console experience. You should also be able to set the value of things, so you can start to mess around with the state of the application while you're debugging it. So if I did watch demo value equals 4, it will just return the value that I've set. But then if I hover over it, you can see we've just set that to 4. So we've intervened in the state of the application while it's paused. It's so powerful. And that allows you to test lots of different scenarios. So very often you could say, you might have an application which is running only if an invoice value is over, say, $10,000. But the data you've got is all just below that, and you want to try and test that other scenario. Well, you could quite easily take a variable like invoice total and then change it inside the immediates window to test that flow of code. You can also do that from the variable itself in most cases. So you can say, change it from here. And then if I go back and type this in again, and you can press up as well, just like you can in the command line to get what you've recently typed in. And I can see it's 6 because I've just set it from elsewhere in the code base. So it's, again, this is where debugging gets a little bit, it's not just looking for bugs. You might also be using it to influence state.
Mm-hmm. Yeah, the immediate window is pretty powerful in its own right. um, there are lots of people who really kind of do all of their debugging in the immediate window a lot of the time. I'm personally one of those who doesn't really use it that much, but yeah, again, whatever floats your boat. There's lots of options in Visual Studio.
Yeah. Yeah. I mean, if you were looking at, say, again, I'll use the example of JSON or XML, it might be just too much to look at in the debugger. But there's nothing stopping you from doing a file.write all text in the immediate window and just then dumping all that information into a text file or a XML or JSON file so that you can then look at it all at the same time. The application's still paused. You're just giving yourself a bit more of an opportunity to view it in something like Visual Studio Code, for example. So it's just, for me, it's just super flexible. I've got options all the time when I'm debugging in Visual Studio. So inspecting variables, we've pretty much covered. That is where you can just hover over them. You can see, as we said, this is still 0 until we actually execute it. And then we get on to something that has thrown me before, honestly, because I feel like they're quite similar. I don't know where you are on this, Leslie. But
Gosh, I still struggle with it too sometimes. Honestly, I think in most cases it's okay to lump autos and locals window together. But if the watch window is like your inspection window for being able, but you have to manually select which variables do you want to have persist and take a look at as you're going through your code. The locals and autos windows automatically give you the variables that are currently in the scope of where you're at. So if you swapped over to the locals or autos window right now, then you'd be getting a lot of the variables that are both within a scope or in proximity. And I think the autos window is really just more proximity focused, more so than scope. It takes the nearby variables, not necessarily all the variables that are currently relevant. So,
yeah.
No,
I think sorry, Leslie, you go on.
No, go ahead.
I was just going to say, I thought that was a really good explanation. I think I looked for a definition before the show because I like to be prepared. But autos, it was kind of defined as a reference to any code which is relevant to the current line. But that's a really vague definition, isn't it? It's really hard to make that accessible.
I agree. So that is my best interpretation of it anyway, just through observation. But I think at the end of the day, a lot of the time the autos and locals windows are pretty much one and the same. I prefer the locals window because, again, you usually get more info that you'll probably need. But yeah, both are giving you the most relevant variables in some capacity, in addition to other default expressions that might come about, which I talk about in other demos that I've done that are really cool, stuff like return value, which can tell you the value of a return statement in your method without having to necessarily set an arbitrary variable. Like the locals window and the autos window can tell you that automatically the moment you step over that line, which is really nice.
Super cool. It's really nice. One thing I do really love as well that you guys have put in is this idea that you can't get away with changing something and not being found out. So here, for example, if you remember, I've changed these values while the application was paused, and Visual Studio is flagging those in red to say, hey, these were changed, which, again, is super important. I think this idea of traceability in debugging, it's got to be forensic, hasn't it? You've got to know absolutely every single thing that's happened and has changed. So just that simple feature of coloring those in red, I love that feature. I think it's really cool.
I agree.
So I think we've agreed most of the time we're going to use locals, but again, totally your choice. But, it's just about having as much visibility as possible. And I know that when I go to locals, I'm always going to see things that are in scope, which is most of the time what I'm concerned with. So this brings me on to my last example, which is one that definitely tripped me up when I was a junior developer. I hated looking at it, not because it was a Visual Studio thing, but it was just a programming thing.
Weird,
it was just a wall of text.
Mm-hmm.
But it becomes less scary over time. And that's the call stack. And actually, Visual Studio does a really good job of visualizing it, whereas the traditional call stack is just like a big line of text, a block of text, sorry. But the idea on the call stack is simply the everything that's happened up until this current point and a representation of that. So you'll often see these in exceptions. So when you do a try catch and you hit that catch, there's going to be some kind of exception object, and that exception object will have a call stack in it, and that will say that the exception threw at a certain point in the code, but before that, lots of other things happened, and those things could be other threads, they could be parent functions, but the common denominator there is that it's before the current point.
Yeah.
Or it's
I
the
think it's like a
original.
timeline of
Yeah.
events that are going on in your code in a lot of ways.
There's a much nicer way of referring to a timeline. Yeah, definitely. So what I've done here is just created a means of viewing the call stack. So we've got a method here called call stack demo, and I'm going to step into it. So I want to go into the actual method. I've pressed F11 for that. And then I'm going to let these pieces of code run. So I'm going to press F10 to step over. I'm going to step over again to get to this method. So we've got a method inside a method. And then I'm going to step into that, and we're going to run that method. And then I'm going to pause it there for a second. If I wanted to see the timeline, as Leslie said, which is the call stack, I can go again into debug, and we've got a really useful Windows section here, which gives us loads of different features, some things that are more advanced than this in the scope of this video, I think. But the one we're interested in is call stack. And you can see here, you can select it, and it will open up the call stack window. So I'm just going to move this. I'm going to try and dock it up here. There we go. And just bring that across. And so this gives us our timeline. This is the stack of events that have happened to bring us to this point. And at the top, you'll have the method that you're currently in, or the breakpoint that you're currently on. So you can see here we're in call stack submethod at line 73. But before that, to get there, we'd hit line 67. And if I double click, it will take me to that line. And again, we can see at the bottom of the call stack, that is going to be the first point of entry, our entry point, because it's the first thing we went into, and that's main, as it would be for our console applications. I think it just hasn't. There we go. Oh, sorry, it's I am in main. Yes, of course. So it's highlighting call stack demo, but that is in the scope of main. So you can use this to trace back what's happened to that point. So I often find it's a useful refreshing tool if I'm doing a very long debugging session. So, and if I'm doing a long debugging session, it's probably a pretty complicated bug. But what I mean by that is if you've spent a lot of time going through lots of different breakpoints, it's quite easy to sometimes forget what's happened up until that point. And that might be really important because you might not be seeing any exceptions throwing, but the data that you've passed through up to that point might be critical to understanding why something isn't running the way it should be. So if you're in that really annoying situation where you know there's a bug, but everything looks good, the call stack's really useful because you can say, okay, I'm going to retrace my steps. And I guess that's the main use case for me. I don't know, Leslie, any other sort of go-to use cases for the call stack that from your side?
Yeah, a kind of niche one that I use it for is in the event you've got a variable that's being changed in a spot that you did not expect it to change, but you also don't really know where that change could be coming from. One of the breakpoints I hinted at earlier, there's one called the data breakpoint that lets you break your or it lets you pause your application when a specified variable changes. at any time. So it's really nice because it'll take you to that exact place where that variable was changed. But there's a specific instance where in the event that variable is actually like a property in a class or something, it's usually going to take you to like the setter that you probably set up for it. But that's when you can use the call stack to figure out who you can really blame. Figure out what method just incremented that variable without your permission and navigate to it that way, which is very helpful. So in some ways, the call stack is like the get blame equivalent of debugging, where it's like, okay, what happened through my code, and could there be a spot where I didn't want that to happen, or a method to be called in a place that I did not expect it to be called. So
there you go. So there's no escaping in Visual Studio. Forensic data everywhere you go. Everything's traceable.
Yeah. Absolutely. And you did mention also threads and stuff. I think the call stack is really useful for if you're dealing with multi-threaded or asynchronous applications. There's lots of instances where you just want to be able to break down what is happening on a specific thread or across multiple threads. Having the call stack window for that is extremely important, I think.
Absolutely. And debugging multiple or parallel execution or concurrency that's probably a video in itself, isn't it? That's it's pretty advanced, but and it still hurts my brain. But there's a million different tools at our disposal here, so it always makes it just that bit easier.
Mm-hmm.
So I mean that's my overall set of examples for an introduction to debugging. But I think key takeaways there are that the emphasis is, as I said, on being as forensic as possible and making the state of any application available to you at that point in time. And my advice to any new developers or any people using Visual Studio for the first time would be to just start with breakpoints and work your way up through these examples we've looked at. I'd say, mess around with the immediates, figure out how you can influence the state of the application and break it, essentially, and maybe create some weird edge cases. And I think once you've had that hands-on experience, you become so much better at debugging in general. And it's often a process of elimination as well. So, you test your theories. You think, I've got a bug. I think it might be this. Let's try and disprove that. And hopefully you're right and you don't have to disprove it. So you can just put the fix in.
Yeah. I think something that helps me with debugging is just the whole expectations versus reality. So like, if you're thinking about the meme, that's kind of the thought process with a lot of debugging. It's like, okay, what did you expect to happen? But what did you actually end up getting? And that gives you a good starting point for, okay, how do we get to that cake looking like what it was supposed to look like instead of my mess of code. Kind of looks like a tennis court, but really it just looks like a blob.
It's definitely when I'm baking cakes, for sure.
Oh, yeah. Awesome. Well, Nick, I thought that was a great introduction to debugging. I think that's something that everyone needs, like whether you're being formally taught it or not. Like I was never formally taught how to use the debugger. And then like I joined the debugger team fresh out of college and I was freaking out because I was like, I just use print statements when I was debugging in school. So like, I don't know. But I think these are really useful tools that really you can take anywhere, whether you're in VS or in another IDE, but you should totally use VS because the debugger is amazing. But yeah, that's awesome. So where can people go to learn even more about debugging, Nick?
Well, of course, you can go over to Microsoft Learn. You've got lots of different videos there and documentation. I think I've got a few videos on debugging. If you want to head over to Nick Proud Programmer, shameless plug. The documentation for Visual Studio in general is fantastic. I'm using Microsoft Learn a lot myself, specifically for the Azure stuff as well. And you can, there's nothing worse than poor documentation, and I've just never had that issue with Visual Studio. And obviously the help function in Visual Studio itself, you can get through to all the documentation you need from the application. In a lot of cases as well, I've noticed recently there's been links to GitHub repos for specific items as well, which is just so cool. If you want to get some information on a specific element of .NET, for example, which is largely open source, you can get straight through to the repo from Visual Studio. So you can't really go wrong with the official docs, and then obviously resources on YouTube and places like that are probably next bet.
Yeah, awesome. And then also more shameless plugs on my end. I know it's been a minute, but this show, the Visual Studio Toolbox show, actually we did do a couple episodes way back when about debugging. So if you're on YouTube right now and you do VS Toolbox debugging, then there should be several videos that pop up, including one that I did on more of those advanced tips and tricks that we talked about. Most of them, I haven't done that talk on the show since VS 2019, but a lot of those tools are still very relevant for VS 2022. And also, if you're on Twitter, make sure you subscribe to VS_debugger. That is a great Twitter channel that's run by the debugger team on Visual Studio. And they drop just cool tips and tricks at random, or sometimes not at random. Sometimes they're talking about new features, because we're always working on new stuff too that are worth checking out. So make sure you're subscribed to that. And yeah, I think that's all of our resources for now. Hopefully that gets people started. So yeah, Nick, thank you. Yeah. But Nick, thank you so much for coming on the show. Super informative, very important stuff.
Absolute pleasure. Thank you so much.
Awesome. And thanks to everyone who's been watching this and is ready to kickstart their debugger journey. And until next time, happy coding, y'all.